All right, so here's another unprepared stream. There's been a lot of progress in DreamSTer, I guess, is the overall project name. The past week, we had several releases. There is performance speedups. There is all kind of fixes. And I figured I'm gonna try to keep this like once per week streams to cover more technical details of the changes. Uh, so before I start though, I'd like to show a quick teaser of where things are right now. Uh, so let me try that. This is Rayman 2. It's one of the best running games right now. Some of them are also, some other games are also performing in a similar way. I'm just gonna let this run for a moment and then we'll move on. Okay, I think that's enough of that. Let me close down that window. Okay, so as you noticed, it runs pretty smoothly. This is with an optimized configuration. We have this new mode that's called Prioritize Audio, and this game does native frame skip, so when the emulator is slow, it just skips frames very gracefully. So this way we don't get any dropouts. There's a few games that are like that, like Toy Commander is another one, Donald Duck, Going Quackers I think is also another one. It's not the majority of games. The majority of games expect higher CPU performance and high rendering performance, and depending at times, we don't hit one or the other. CPU is 60 to 80% most of the time. GPU is sometimes full speed, but especially when there is a lot of transparency involved, then things can go really, really slow. Uh, with that, I'd like to start with a big shout out on to Pixel Cherry Ninja. He has been covering this a lot the past week, I guess, or more. And he did a really interesting testing stream last night, like really late as well. So kudos for that. I'll let a link below to the stream. You can take a look on his latest updates, and also if you want to see the stream, it is over here, it's this one. A lot of notes for me, like some default configurations that need to change on the emulator, and also I'll see if I have time to create bug reports of my own based on what we see on the feedback on the video. But yeah, let's get on the more technical stuff. As I said, there's been several releases. There was actually even an R0 that was in Discord only release. We can quickly go over them and see what got changed. So yeah, here we have input support, uh, HDMI fixes, some instructions how to use it, then UI fixes like for people that have zoomed in, fix the HDMI. Then we fixed some reset issues like if you played many games, the display would corrupt itself and you would have to reboot your mister. Then more HDMI bug fixes. Then some optimizations in the tile accelerator included bugs that got fixed. Maybe a little bit better stability. Then we had some reports, especially when trying out this with real people, that people just pressed the B button and exited the thing and couldn't get it working. So now there is a special exit menu option. Audio support, we have 21, I think it's 42 actually, but anyway. A millisecond sound FIFO. That's a little bit long, but it's required right now to absorb the stuttering and the time dilation that happens on the emulator side, like on the CPU emulator side. We hope to improve that. It's still much better than a software emulator, like running on Windows on top of the entire audio streaming pipeline. Video latency is much lower, of course, because it's running directly on the FPGA. Then stability fixes for multi-threaded tile acceleration. Now it should be the default mode, the full. We haven't found any glitches with it, but just as a precaution, I've left the safe version as the default. Then we added the nice status bar on top that you saw in the live stream. And then in the latest release, we fixed some issues in the triangle setup. Just to get you in on the technical details, most of the floating point math is done with 15 bits of precision for the mantissa. That's like the precision after the 1 point something in the floating point representation. But for the triangle setup, we extended that to 23 bits and it fixes most of the corruption. There is a new free running mode for this H4. This is like the prioritized audio versus prioritized video. It makes FPS slower, but tries really hard to keep audio smooth. So depending on the game, this might work better for you, or maybe it will crash the game. And then some minor optimizations. I did some more SH4 side optimizations, like on the emulator on ARM, but they didn't really pan out, so that was a bummer yesterday. But sometimes it works, sometimes it doesn't. So, one thing that's important, we have this DreamSTer repo, and we have this tracking here, and we really need your help to fill in this with reports for more games. I will go in, like the new reports have this tag, and I will be going over and assigning tags and annotating, and this is very helpful for us to understand what is broken in the minicast, because it's a very weird fork of an old emulator of mine. So I need to understand what's broken in it and what's misconfigured in it, like we saw the performance configuration problems. Yeah, thank you. And then this is a place where the community could really help us. Making in report, you just click on the new issue, game compatibility report, then you fill in this form, then you press create, and that's all. We can go in Cosmos and see the report that was done. Like this stuff is really helpful because then I know exactly what to go in and look for. Instead of spending hours and hours testing games, I can spend it writing code. Okay, so first of all, there has been a lot of code reorganization. Now there is this DreamSTer master repo. This contains 3 projects: Poly2RTL, which is the FPGA bits, minicast, which is the emulator bits, and GLDC, that is an OpenGL implementation for the Dreamcast that has been ported over to work with Poly2RTL. This means you can actually use OpenGL to do 3D graphics on the Mister, the D10 Nano. Uh, I just did that because we might use it for some fancier UI or for porting things like Jailquake. I don't know. It was easy, so I did it. The way it works is that little code is in this repository. It's actually only the scripts, the DreamSTer like script that is the terminal UI that you see, and then the README that has some instructions on how to get started. Uh, then all of these are links to other repositories where the actual development happens. You can follow progress with pull requests. We will be opening pull requests for everything from now on. So if you want to see what has changed, you can go here. Like for example, there were two pull requests, first by anim0taku, I guess, uh, to add selection for USB, then BD, I don't know, then somebody else did the follow-up on that. I guess the coordinate, I don't know if they coordinate or not. You can see there is a nice write-up of what it does. This has been merged, it will be included in the next release. Uh, there is also the issues. Yeah, we covered that. Okay, so let's go on minicast. These are the improvements that have been happening, the pull requests. So let's cover them. First of all, apart from the organization on having this parent DreamSTer project, there has been a lot of cleanup on the repositories. So we have the first request was the first pull request was D10 Nano support. Uh, you can actually go into these ones, and I try to keep a write-up of what has changed. I'm gonna do a better job now that we are more public. You can also see a more detailed log of each change by change, and then, yeah, the merge. So, initial support for the Mister board, then the parallel TA handling, that was an optimization improvement because the tile accelerator is kind of expensive. We are considering to move that to the hardware if it fits, but there are other problems there, like we can't get data fast enough to the FPGA from the CPU. Then it was support for joysticks. Then we updated the Poly2RTL to have a proper driver interface so we can stop abusing things and copy pasting code over and over. Then it was the audio support with our new driver, the stats, the OSD, some further cleanups. Yeah, then the mentioned multi-threaded TA cleanup, then optimizations that didn't pay off, and another optimization that didn't pay off, but we got the merge, and then the free running mode. As you see, this is kind of self-descriptive. Yeah, I don't always provide descriptions. I will try to do a better job on that one. Let's see what's next. Yeah, there is the issues tab where you can kind of see our ideas for the future. This is not meant to be for the users. This is meant to be maintained by the team. So unless you are willing to contribute code and know your way around FPGAs and emulators, please don't open tickets there. Do that in the main DreamSTer repo. But you can kind of see our wish list slash roadmap for the next some time. There's no commitment, fixed commitment in this, so things may move fast or may move slow. Yeah, let's switch over to Poly2RTL. There haven't been many things here. There's been some optimizations. It used to take 95% of the FPGA. Then there was some cleanups and optimization for performance. So we were up to 72 megahertz. Now we clear 75. Well, we were clearing 45 megahertz and running at 72. Now we clear 75 and we run at 112. It seems stable. So this is all of those. Then there was an optimization in the texture cache. So when we are shading a pixel, we need to fetch the texture contents for that pixel, and we need to do it up to 4 times because we do bilinear filtering for most textures. I mean, the game asks us to do bilinear filtering, and we observe that. So this was a fix for that because we used to only fill each. We have 4 caches in order to be able to serve 4 pixels at once, and we changed the behavior of how when something is not in the cache, it gets filled in the cache in a way that performs much better, like twice better texturing performance. This is an open work in progress. Uh, I have some really good ideas on how to speed this part further. It's one of our bottlenecks right now in the hardware. Also, I biased the MIPS once so that it used the bigger MIPS, but that creates aliasing, so I undid that. But we still have aliasing, so I need to take a look at the MIP mapping selection code. Then was the short cache. This one is an interesting one. Again, I will do a better job from now on with write-ups, so we'll be also doing these streams. This is also a process for me. So when we have alpha blending enabled, like transparent stuff, we have to sort them from the back to front, so they are drawn in the correct order. This lets us know when a triangle has been fully drawn, so we don't have to reprocess again. This is called discard processing in the original hardware. This double performance in scenes with heavy alpha blending, we are still very slow, but it's half as slow, so that's something. Then some optimizations. So we have 8 ISP comparison units, and we did the final add and then compared that if it's bigger or equal to 0. But we can just not do the add, which is very expensive, and do the compare between the two numbers, like the target, but the thing that's added, and the other value, instead of adding them together and checking if they're bigger than 0. So we did that. That saved a big chunk of the FPGA. Yeah, then I cleaned up the code and reorganized everything, and this is a mess, but this is what added the new Mr. Harness. Like, we removed the ASCAL, the Mr. FB, all of that stuff, and we kind of took over the board, which is required. This is a little bit nasty and removes some features people are used to, but this got our compile from 95% full to 72% full, so we now have space to do more stuff on the FPGA, so it was really important. Yeah. Then we added the audio driver. It's 2048 entries of left and right samples. It's very small. Uh, if you're technically inclined, you can see on the file change and you can actually see the code changes. This is both Verilog and driver. I'm just saying that if you're really curious to see how we get our work done here. Then the two status reports were added. Like you saw, there is an FPS display on the top, and we can also display stuff on the bottom. This works by having 2 extra frame buffers that the emulator populates, and they're drawn, and then we just display them. So there's actually 3 buffers that we display: the top display, the main game content, and then the bottom display. We're thinking to use the bottom display to add version information, so we know exactly, we can take a screenshot or a photo and we know exactly what version we're running. We also want to add an option to make these hidden, but I think they should be visible by default right now, so that the reports are more helpful for us developers. Yeah. So, yeah, this is a funny title there. I was happy. This is a triangle setup fixes, so it's the extensions from 15 bits to 23-bit Mantinsa. In the future, I will include some photos here so you can see before and after. But if you've seen videos last week and the videos like from yesterday, you know what is fixed. Pretty much all of these swimming large polygons that are close to the camera that were glitching on and off. And then we have interrupt support. What this enables us is when the hardware is done drawing something, it tells us it's done instead of us having to ask it, are you done yet? Are you done yet? Are you done yet? So that's all, I guess. Let's see what else I have. Yeah, we also have issues here with some further optimizations, ideas, wishes like VGA output. VGA output is actually an interesting one because we can do it the way the hardware does it and use the real Dreamcast display modes. We might keep a separate HDMI and VGA output build. The thing is, as you saw earlier, I use an HDMI capture setup, like it's a KVM, so I can connect over the internet to my Mister. It's not even near me. The Mister is in my garage. So that's not likely to be the default until we are much further. But yeah, bump mapping is another one. Some games use it, like Rayman use it. Optimizing some operations. These interrupts are done. Then pixel centers, these fix this problem where some pixels seemed misaligned. You've probably seen in fighting games or in 2D elements, there's some weird lines going on or some things look a little bit shifted by one pixel. That's it. Also pixel centers. Then some optimizations for our depth buffers. Yeah, also more pixel center work, like this is to separate them and this is to do them correctly. Then some caching work and correct video out. Right now we do 565 RGB, but the Dreamcast supports several video out modes and we need to correctly do that and follow the registers. And yeah, I think that's all I have for today. Yeah. So I hope you enjoyed Thanks for the comments. I hope you enjoyed this quick stream. I will get better on those. I'm gonna try to keep you guys updated at least once per week. And there's gonna be also updates on Twitter and on the repositories. Oh, another one. Here in the DreamSTer main repo, we made two channels in the Impossible Ports Discord server. So some of the chatter is gonna be there, like both for development and general support. We are also active on the Mister Discord, but this is kind of escalating, so we figured we might as well do this on another server. The Impossible Ports was a server I set up for the Grand Theft Auto 3 and Vice City port to the Dreamcast. It was a project that I started and now it's kind of finished slash stalled slash needs more work, but I'm working on this instead. So we figured we might as well use that community. I did a poll there. Everybody, well, many people were happy with us having two extra channels, so that's how it is. Yeah. So join us on Discord, ask questions, hit us on Twitter, whatever. Peace out.